we just finished looking at the relationship between time measured from the perspective of a moving observer, and time measured by a stationary observer. Right, we call the clock that was stationary, we call the time passing on that clock tau. Let's just use coordinates t. So we found this relationship. This is the time dilation. And then we looked at distances. We found length contraction, the x bar related to the x by the same term. So time dilation and length contraction, bar coordinates and unbarred coordinates, so x bar, t bar, as a function of x and t. And so we have some positive coefficients here. So we could think of t bar, right? So what are the mathematical functions that get us from x bar and t bar, that get us x bar and t bar from x and t? So we're looking for something like some coefficient, let's call it b, right? In terms of x and t, we could say something like that. Although if we're careful, b and c, just from dimensional analysis, are the same up to a factor of v. And we could say x bar is also a function of x and t. What's that function? Well, now we can see it more directly, that there's just we don't need to add an additional term. Let's just say x minus vt. So we want to find what are these quantities. So we want a, b, and c. C will be b times a v, but we want to know whether it's a plus or minus. So those are the functions that we have, and the mathematical transformation will allow us. So we'll think of the invariant interval, and then we'll get constraints on a, b, and c, and we'll see what the mathematical transformations are. So let's square these quantities, right? So we know that t bar squared minus x bar squared is equal to t squared minus x squared, right? That's the invariant interval. So what is that like in terms of these quantities? So we're squaring this thing, so we get a bt plus cx squared, so we have bt plus cx squared minus we want minus x bar squared, so it's this thing squared, so that looks like a squared times x minus vt squared. And what is that? So that is, so now we just have to do the algebra. It's b squared t squared plus c squared x squared, and we have the cross term 2b cxt, cross term here. Then we have minus a squared. We're going to square this, so we get x squared plus v squared t squared minus 2vxt. So let's combine like terms, like t squared and t squared here. So we get, let's see, b squared minus a squared v squared t squared plus c squared minus a squared x squared plus the xt term has coefficient 2bc plus 2a squared v xt. And of course, this has to equal to t squared minus x squared. So this tells us that let's see, we end up with this first term, right? We have b squared, so one condition is b squared minus v squared a squared, this term, that has to equal to 1. Then we have second term, which is this one, c squared minus a squared, that has to equal to minus 1, because it has to reduce to this. And the last term, so equation 3 is bc plus va squared. That needs to cancel out. So those are the 3 conditions that we get from there. Let's see here. So let's see, multiply. Let's see if I can do this. So let's multiply equation 2 by v squared. That gives us a v squared c squared minus v squared a squared. That's equal to minus v squared. If we subtract from 1, then what we're doing is we're trying to get, let's see, trying to get b by itself. So I do b squared minus v squared a squared. That's equal to 1. And then I have minus v squared c squared plus v squared a squared. That's equal to v squared. I'm going to add these two. Actually, I'm going to add them, not subtract them. So I get, I'm trying to get rid of, so I'm getting rid of a here. I get b squared minus v squared c squared equals to 1 plus v squared. And then from 3, so from 3 I have bc plus va squared is equal to 0. So from 1 I have that v squared a squared is equal to b squared minus 1. And so a squared is equal to b squared minus 1 over v squared. So let's put that into into 3 here. So let's get another sheet. So we end up with, so I have a squared equals b squared minus 1 over v squared. So now we have bc plus, so this is 3, bc plus b squared minus 1 over v. That's equal to 0. And that gives us c equals 1 minus b squared over v times b. Let's put this into the equation b squared minus v squared c squared, which we derived to be 1 plus v squared. All right, let's put the c in there. So what do we get? We get b squared minus v squared times c squared, which is this squared, so that's 1 minus b squared squared over v squared b squared. That's equal to 1 plus v squared. So we get b squared minus 1 plus b to the fourth minus 2b squared over v squared b squared. It's multiplied by v squared. Sorry, we canceled. The v squared is canceled, so this becomes 1 plus v squared. So we want to work this out. What does that give us? We get, we have b squared minus 1 over b squared, which is this term. We get, next one is a b squared minus b squared. Then we have a 2, the b's cancel, we have minus and minus, we get plus 2 equals 1 plus v squared. And so this gives us b, right? So we have one equation for v. This cancels with that. We have a minus 1 over b squared. We can bring this to the other side. So we get 1 over b squared is equal to 1 minus v squared. Because this is, if we bring this side, we have a minus 1 plus v squared, but we flip the sign here to get a positive b. So b becomes 1 over, and we take the square root of this, and we want a positive quantity. So we choose the positive root. So that's our b coefficient. So a little bit of algebra to get the b coefficient. So let's see, we are, so from one, v squared a squared is equal to b squared minus 1, and that's equal to 1 over 1 minus v squared, right? Because that's this squared minus 1, but that's the same thing as 1 minus v squared over 1 minus v squared. And so v squared a squared is equal to v squared over 1 minus v squared, right? So this is equal to this, and so we have a is therefore 1 over 1 minus v squared, and so a is the same as b. A is the same as b, and now we can get c. So how do we get c? So we have c squared is equal to minus 1 plus a squared, which is equal to minus 1 plus, we square the a, minus 1 minus v squared, which is equal to minus 1 minus v squared plus 1, all over 1 minus v squared. And let me get a sharper pencil here. So this is equal to v squared over 1 minus v squared. And so c, the coefficient c becomes, well, plus or minus. We don't get actually to determine that. So that's open. But from bc plus va squared equals 0, we get c over 1 minus v squared square root plus v over 1 minus v squared. That has to equal to 0. And so c is actually minus v over 1 minus v squared square root, and we have c. And so it's actually minus v times b. And so what we found is that there's a mathematical relationship between t bar and x and t, which is 1 over 1 minus v squared times t minus v over 1 minus v squared square root x, and x bar and x and t, which is 1 over 1 minus v squared square root times x minus vt. Right, these are the so-called Lorentz transformations.